So in today's class topic, we discuss about the tangent plane to the sphere and problems related to tangent plane. So if you imagine, whenever you consider a sphere which is touched by a plane, then you get exactly one point which is common to both the plane and the sphere. So such things we call it as the tangent plane to the sphere, and obviously the checking condition would be if we calculate the distance from center of the sphere to the plane, it will be equal to the radius of the sphere. You have known this already. Now coming to the point, whenever a point is given to you, then how to calculate the tangent plane of the sphere at that particular point? So for this, there is a simple formula available. If you take that given sphere is S, then equation to the tangent plane at a particular point is S1 equal to 0. So the notation is xx1 plus yy1 plus zz1 plus uv into x plus x1 plus v into y plus y1 plus w into z plus z1 plus d equal to 0. So this is the thing. So this entire formula will be simply denoted with the symbol S1 equal to 0, where the values of u, v, w, d are nothing but the values of the sphere equation. Okay? Please take a note of that. After noting, please tell. So we simply call it as S1, the equation of the tangent plane. So S1 is nothing but tangent plane equation. Whenever a point is given to us, at that particular point, you are calculating the tangent plane of the sphere. Fine. So this is the abbreviation of this one. So let us take a small problem right now for an idea. You take the sphere x square plus y square plus z square minus 2x minus 4y plus 2z plus 3 minus 3 equal to 0. And I have given a point to you which is minus 1, 4, minus 2. So I have given the sphere equation for you. I have given the point x1, y1, z1 to you, so that you can compute the tangent plane, nothing but S1 equal to 0. So from the plane equation, uv is nothing but minus 1, v is minus 2, w is 1, and d is minus 3. So I have given a formula earlier to you. So please substitute the values there and compute the tangent plane equation. I say that you will get the equation as 2x minus 2y plus z plus 12y equal to 0. So please check on that. So everyone, please confirm your answer. Have you arrived with this plane equation or not? So if everyone agrees with that, then I will take the other model. In the meanwhile, let me know, I have given a sphere S and a point. If you want to know whether this point belongs to the interior of the sphere, or it is lying on the sphere, or it is outside of the sphere, how do we check? Any guess for anybody? In other words, if I have given a point and a sphere equation, you should know whether the point is an internal point, external point, it is on the sphere. How can we check? Yeah. So we simply substitute the point in the sphere. So you will get a number. So if the number is greater than 0, it is an external point. If the number is less than 0, it is internal point. If it is equal to 0, the point lies on the sphere. And the thing what you are substituting, the value, we generally denote with S11. So this notation tells us that you are substituting a point in the sphere S, and this is the result. Okay. The value after substituting the point in a sphere equation is nothing but S11. It may be a positive number or negative number or equal to 0. Fine. So please take a note of that. Now let us go to the other model. Two x minus 2y plus z plus 12 equal to 0 touches the sphere. X square plus y square plus z square and find the point of contact. So we have to show that the plane touches the sphere, and hence we need to calculate the point of contact there. Okay. So you know how to do the problem. I will give the procedure one more time. So from the sphere equation, its center is nothing but 1, 2, minus 1. And could you tell me the value of radius there? Substituting the values in the radius formula. 3. So if you say that the plane touches the sphere, obviously the checking condition is distance must be equal to radius. So you are calculating the distance from center of the sphere to the plane. So if you calculate that, the values, so 2 into 1 minus 2 into 2 plus 1 into minus 1 plus 12 by square root of so please check on that, are these values equal or not. So you are getting 3 is equal to 3. Distance is equal to radius. Please check. So for a rough visualization, you can have the picture like that. Whenever the plane touches the sphere, distance is equal to radius. So please take a note of that. Now the second part of the question is, we need to calculate the point of contact. So how do we calculate that? From the picture, what we can say about it? So if you observe that the distance line is perpendicular to the plane, so it is nothing but it acts as a normal to the plane. So the foot of the perpendicular is nothing but the point of contact. So we need to construct a line equation from the center of the sphere to the plane. So if you write the line equation, it will be x minus 1 by 2 is equal to y minus 2 by minus 2 is equal to z plus 1 by 1. So here in the denominator, I have taken the plane drs. In the numerator, I have considered the center of the sphere. So if you write the respective parametric form, anything would be of the form x is equal to 2r plus 1, y is equal to minus 2r plus 2, z is equal to r minus 1. Since the foot lies on the plane, in other words, the foot is nothing but the point of contact which is common to both sphere and the plane. So if you substitute the three values in the plane equation, so you have 2 into 2r plus 1 minus 2 into minus 2r plus 2 plus 1 into r minus 1 plus 12 equal to 0. So simplifying that, you will get the equation that r is equal to minus 1. And the point of contact is minus 1, 4, minus 2. Please check. So if everyone is clear with this solution, please take a note of it. I will go to the other problem. Let me know after noting this. If anybody has any other queries with regard to the approach, you can ask. Right. Find the equation of the sphere which touch the sphere x square plus y square plus z square plus 2x minus 6y plus 1 equal to 0. At the point I will say 1, 2, minus 2, that I will take 1, 2, minus 2. And passes through origin. Right? So please take a note of that, then we discuss with the approach. So if you draw a rough picture of the question, let us take that this is our given sphere. And the point 1, 2, minus 2 lies on the given sphere. So we have to calculate a new sphere equation such that the new sphere touches this at the given point, and also the new sphere passes through origin. So this is our required sphere and this is the given sphere. Clear to all? The diagram? So this is our given sphere, this is our required sphere. Now I request you to calculate the tangent plane at this point. So we have to calculate the tangent plane at 1, 2, minus 2 for the given sphere. So using the formula S1 equal to 0, you can find it. The equation of the tangent plane is nothing but 2x minus y minus 2z minus 4 equal to 0. Could you check on that by doing the substitution? Please tell. So I am saying that please calculate the tangent plane for the given sphere at the given point. So using the formula S1 equal to 0, the equation of the tangent plane will come as 2x minus y minus 2z minus 4 equal to 0. So you please check that. I will wait. Now, why I have calculated the tangent plane here? That was the question. If you calculate the tangent plane at this point, in other words, the given point 1, 2, minus 2 is the common part for the given sphere as well as the plane. Agreed? So the point is common to both given sphere and the plane you have obtained. Accepted? it belongs to the intersection of the plane and sphere because it is common to both the things. Agree, all of you? So as we know that whenever a plane and a sphere intersect, it is nothing but a circle. So here the circle is nothing but a point. So we have to treat the point as the point circle. So a circle whose center is there and radius is 0. So we treat the point as the point circle. So the new sphere, as per the given data of the problem, passing through this point. In other words, the new sphere passes through the circle here, which is nothing but a point circle. So obviously, I can make use of the formula s plus lambda pi is equal to 0. So why I am using this formula? The new sphere is passing through the intersection of these two, which is nothing but a point circle. That's why I am using this formula. So substituting the values here, x square plus y square plus z square plus 2x minus 6y plus 1 plus lambda into 2x minus y minus 2z minus 4 equal to 0. In order to determine the value of lambda, the respective condition is given in the problem that the required sphere is passing through the origin. So if you substitute 0, 0, 0 here, you will get that lambda is equal to 1 by 4. Accepted? Hence, substituting the lambda value, the required sphere equation is nothing but 4 into x square plus y square plus z square and plus 10x minus 25y minus 2z equal to 0. That was the solution. That is the equation of the required sphere. Now you can understand the importance of tangent plane for this problem. The applicability of s plus lambda pi equal to 0 here. Agreed? So please take a note of that. If anybody has any other questions, you can ask. The approach of the problem. Any doubts with regard to the concept and ideology to solve the problem? So this is also an interesting problem. Find the equation of the sphere touching the plane three x plus 2y minus z plus 2 equal to 0 at 1 minus 2 1 and passing through origin. Take a note of the question. After noting, I will draw the picture so that we can discuss what is the approach for the solution. Right? So let us take that this is our required sphere having some center. As per the problem, the sphere touches the plane, say this is the plane given at the point 1 minus 2 1, and the other condition here is it passes through origin. Now how to evaluate that? Now just think that if you want to write a sphere equation, what are the basic criteria we want? What are the inputs we require to write a sphere equation? Center and radius. Accepted? Right. When points are there, u, v, w, d values are required. Otherwise, if center and radius is known to you, you are able to calculate the sphere equation. Accepted? So apart from this, any other criteria is there to write the sphere equation? If 2 points are given to us, can you write the sphere equation? Did we learn any such kind of formula? I am not asking about the tangent plane. Just imagine that I have a sphere S. I want to write a sphere S. If center and radius both are given, then you can write the equation of S. Other thing is, if only 2 points are given, can you write the sphere equation? If it is possible that the 2 points are nothing but diameter endpoints, then you are able to write the equation of the sphere. I have given a formula to you already, which is nothing but x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. So could you recollect this formula? So using this technique, I want to solve this problem. So here, let us take that this is the diameter of the required sphere. So here, one end is nothing but our given point. Say this is A. The other end is the point B. We should know what is B actually here. Then using this formula, you can find the sphere equation. I will choose B in such a way that the diameter AB is perpendicular to the given plane. In such a way, I will choose the diameter. So what happens? AB acts as normal to the plane, hence I can write the equation of the normal. So that you have x minus 1 by 3 is equal to y plus 2 by 2 is equal to z minus 1 by minus 1. Taking the parametric form, you have x is equal to 3r plus 1, y is equal to 2r minus 2, and z is equal to minus r plus 1. Please check that. Accepted? Now, any point on the diameter will be of the same form for some value of r. Hence, the end point B is also of the same form for some r. So let us substitute the value in the formula. The value of B, because B coordinates will be of the same form for some r. So if you know r, then you are done the whole part of the problem. So applying the formula, x minus 1 into x minus of 3r plus 1 plus y plus 2 into y minus of 2r minus 2 plus z minus 1 into z minus of minus r plus 1 equal to 0. This is our required speed equation. You accepted all? We can consider point B is also a center. That is also correct. Nothing wrong at all. Now the question is, if you take that the point B as center, then how to determine the center? It is a question thing. So you need to calculate the center. Then what happens? So by taking that it is a tangent plane and doing something extra, you can compute the center. So apart from that, the interesting thing is there is one more condition given in the problem, that the required sphere passes through origin. So if you simply substitute 0, 0, 0 here, you will get R value very easily. Apart from taking B as a center, we can take B as the diameter and point. So determination will be somewhat easy. So if you substitute 0, 0, 0 in this formula, so on simplifying that, I can say that you will get the value of R as equal to 3. Hence you can find the respective speed equation. Substituting R value here, you get B is equal to 10, 4, minus 2. The end point of diameter. So substituting the respective points here, the speed equation will come as x square plus y square plus z square minus 11x minus 2y plus z equal to 0. Since it passes through origin, it will not contain a constant. Is it clear, the approach? So if you have noted this, I will take the next model. Yes, that is also true. We can write the plane equation and compare the coefficients. That is also true. So for a problem, you can have multiple approaches, among which I am taking the suitable one and easy to do at the time of exam. The next problem is find the tangent planes to the sphere x square plus y square plus z square minus 4x plus 2y minus 6z plus 5 equal to 0 at which are parallel to the plane two x plus 2y minus z equal to 0. So please take a note of that. So is the question tag clear, or do you want to explain what to do for this problem? Please tell. Right. Now, first of all, let us calculate the center and radius of the sphere. Center is nothing but 2 minus 1, 3. And if you calculate the radius, it will be 3. Since we have to calculate the tangent plane, and the plane must be parallel to another plane. So obviously, whenever you are calculating the parallel planes, always the coefficients are equivalent and constants will differ. So required tangent plane will be of the form 2x plus 2y minus z plus k is equal to 0, or you can take is equal to k, whatever the case may be. You can take is equal to k or plus k equal to 0. So let us take for convenience, it is nothing but 2x plus 2y minus z plus k is equal to 0. So if you can determine the k value, then you are done. Since it is given that it is a tangent plane, the required one, so obviously distance from center of the sphere to this one is nothing but radius. So applying the distance here, modulus of 2 into 2 plus 2 into minus 1 minus 1 into 3 plus k whole divided by square root of 4 plus 1 is equal to 3. Hence, equating the thing, you can get modulus of k minus 1 is equal to 9. So you can take the modulus value as positive or negative, so that you can take k is equal to 10 or k is equal to minus 8. So if you take that k minus 1 is positive, then you have k minus 1 is equal to 9, k is equal to 10. If you take that k minus 1 is negative, the modulus will come as minus k plus 1, hence k is nothing but minus 8. Accepted? So you have two tangent planes, namely 2x plus 2y minus z plus 10 equal to 0 or minus 8 equal to 0. That is our required solution. The next one is find the equations of tangent line to the circle x square plus y square plus z square plus 5x minus 7y plus 2z minus 8 equal to 0, comma 3x minus 2y plus 4z plus 3 equal to 0 at the point now. Just visualize the problem and try to draw a picture. Then we discuss how to find the equation of tangent line. It is very easy to calculate, but one should have visualization so that it will be done very easily. So first of all, how can we get a tangent line? Or simply, how can we get a line? In other words, So line is nothing but the intersection of two planes. Accepted? So here tangent line is nothing but the intersection of two planes, where one plane is nothing but the tangent plane. Are you getting the idea? Now, if you want to draw a small picture, it is given that we have a circle here. So what happens? This is the required sphere. The sphere is intersected by a plane, so you will get a circle. Now, can you say that the given point -354 satisfies the sphere equation and also the plane equation? So can you check that the point -354 satisfies the given sphere equation? Say. Right. So we can feel that this is the point -354 which is lying on the sphere. So since I know a point on the sphere, at that point I will calculate the tangent plane using the formula S1 equal to 0. So here the two planes intersected, among which one is the tangent plane. Since the intersection of two planes is nothing but a line, so I have a tangent line here. So how do I represent the tangent line? Very simple. I will represent that in the unsymmetrical form, that is writing two plane equations together. I will write one plane which is nothing but the given plane of the problem. Another one is nothing but the tangent plane which I find. So intersection of these two planes is nothing but the required tangent line. So you can visualize that by placing a cardboard on a sphere, on a ball. That visualization will be helpful to you. So just imagine that the tangent plane is nothing but intersection of two planes, the tangent line. So how we are writing the tangent line? By representing it by means of two planes. One plane is in the problem itself. The other plane is nothing but the tangent plane which you will calculate at the point. So in this model, we calculate the tangent line. So for the visualization, just give me a second. I will give a small demo if possible. Give me a moment. So it is just like, suppose you have taken a ball and the ball is cut by a plane. So you will get a circle. You just forget about that. And please understand that the tangent line is to the circle. So where the point is there, it is at this point. So the point lies on the circle. So can you say that the given point satisfies the two plane equations, the sphere and the plane equation? So what happens? So apart from this visualization, you can say this is a circle, let me say. This is a circle formed by the intersection of a sphere and a plane. So on this circle, I got a point here. So at this point, a plane is already attached. This plane is given already in the problem. Now at the same point, using the sphere equation, you are calculating the another plane. So intersection of two planes is nothing but a line. That is the tangent plane. I mean the tangent line. So it is just like, suppose you have taken a sphere, a plane cutted by it. So at the edge of the sphere, you got a point, right? That point is common to the plane, the circle, and also the sphere. It is at the edge. So at the same edge, you are finding another plane to it. Now what happens? The two planes will meet at the same point, so that you will get the line of intersection there. So the horizontal line will be line of intersection into the board. Yeah. Just let us do the problem, then we confirm whether they are perpendicular or not. They need not be perpendicular, right? It is just like a tangent plane. So if you imagine that, say this is one plane. I have calculated the other plane at the same point. So tangent plane will be of any kind. You can take any kind of the tangent plane. It need not be perpendicular to that point. So first of all, let us do the problem, then we discuss. That will be beneficial. So if you apply S1 equal to 0 using the point and sphere, so here UV is equal to 5 by 2, B is equal to minus 7 by 2, W is equal to 1, D is equal to minus 8. So substitute in the values, you will get that S1 is nothing but x minus 3y minus 10z plus 58 equal to 0. So the simple visualization is, you take a ball, at the edge of the ball, I mean the surface of the ball, at a fixed point, you just place two cardboards like this, attaching these two, sticking to one point. So you feel that one plane is passing through the sphere, another is just landed on that thing. At the same point it was landed. So you will get the tangent line, which is nothing but the intersection of these two. That is one simple visualization. Agreed? So please check on that by using the formula S1 equal to 0. Are you getting this plane equation or not, the tangent plane? Please give confirmation. I have given the values already. U is nothing but 5 by 2. If you write the two plane equations together, one is nothing but the given plane, another one is nothing but the tangent plane. You have written the tangent line equation. In particular, if you want to write it in symmetrical form, how do you write? Now what happens? X1, Y1, Z1 is nothing but the point on the tangent line. Obviously, the point is nothing but this. -3, 5, 4. The next thing we need to calculate is the DC's or DR's element values. They will be found very easily because the normals of the planes are perpendicular to the line. Because if you say that this is one plane and this is other plane, so this is the line of intersection, then the normal to the plane is always perpendicular to this line. So applying perpendicularity conditions for the line DRs as well as plane DRs, you will get the two equations as 3L minus 2M plus 4N is equal to 0 and L minus 3M minus 10N equal to 0. So if you solve that, element values will come as 32, 34 and -7. So like this you can write the line equation in symmetrical form also. So you have two things possible. You can write the tangent line equation in unsymmetrical form. You can write the tangent line equation in symmetrical form. The point is already given in the problem. You are just calculating element values using the plane DRs. That's it. So if you are getting bored with this tangent plane concept, then let us wind up here. Is it comfortable to understand or a little bit difficult? Agreed? Where this is the given plane and this is the plane which we calculate. Now we have written the line equation in symmetrical form. If you want to write it in, we have found the line equation in unsymmetrical form. So if you want to write it in symmetrical form, all we need to do is knowing a point on the line and knowing line DRs. The point is already given in the problem, -3, 5, 4. Because at that point only the two planes are intersecting, because the given plane contains this point and at the same point only you have calculated the tangent plane. So obviously the line contains the point -3, 5, 4. So it is nothing but x plus 3 by y minus 5 by z minus 4 by, if you want to write it in symmetrical form. So you should know what are the DRs of the line. So if you imagine that this is the line formed by the intersection of these two planes, as we know that the normal of the plane is always perpendicular to the line. Agreed? So in order to calculate line DRs, we apply perpendicularity conditions to the normal of the plane and the line. So observing the DRs, you will have 3L minus 2M plus 4N equal to 0. If you say that these are the values of element, and L minus 3M minus 10N equal to 0. You know how to solve the equations. We have discussed them so many times. So solving the two things, you will get that L is equal to 32, M is equal to 34 and N is equal to -7. You substitute, you will get the respective line equation. That's it. Right? So can I take the other concept based on tangent planes, which is something interesting for you? How good enough we can visualize the part? Shall I? Right. The best thing of solid geometry is if you have a good visualization over the problem, obviously by using a small formula, you will get the whole concept. The solution will be achieved very easily. If you stuck up with the solution visualization, then we can't do anything. It takes much time. The interesting problem is find the equations of the spheres touching the coordinate planes how many such spheres can be had? This is something interesting question, and it will be very easy if you have a good visualization. So please take a note of that, then we discuss on it. Since we need to calculate the sphere equation, let us take that the required sphere is nothing but x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. If we are able to determine the values of u, v, w, d, then you are done. Now, if you observe the condition, the sphere is touching the coordinate planes. Obviously, it will touch xy plane, yz plane, and zx plane. So, if you consider the respective equations, it is nothing but z is equal to 0, x equal to 0, and y is equal to 0. Accepted? All of you. So, since it is touching the planes, what is the touching condition? Distance must be equal to radius, isn't it? So, what is the radius of the sphere? U square plus v square plus w square minus d. And what is the distance? If you calculate the distance from center of the sphere to each of the plane, all the distances are nothing but equal to the radius. So distance is equal to radius you have. So center is nothing but minus u minus v minus w. You can consider any one plane. So let us say I have taken the yz plane, whose equation is nothing but x equal to 0. So let us apply the distance formula for center and the plane. So here we need to understand that the plane x equal to 0 can be understood in such a way that it is of the form ax plus by plus cz plus d is equal to 0. Please understand that it is of that form. So a value is 1, b value is 0, c value 0, and d value 0. So if you apply the distance formula, modulus, it is nothing but modulus of minus u by 1. Accepted? Please check the distance formula, all of you, and calculating the distance formula for the center and this plane equation. modulus of ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square. So you have distance is equal to radius. So this equal to radius. Squaring on both sides, you get that u square is equal to u square plus v square plus w square minus d. U square gets cancelled. So you have the thing v square plus w square is equal to d. All of you please note that. After noting, please tell. Similarly, you have other distances also. The distance from xy plane equal to radius. The distance from zx plane equal to radius. Using the same technique here, you will get the other equations as u square plus v square is equal to d and u square plus w square equal to d. Are you getting the pattern? How these equations have come? Right. Now, let us add all the three equations together. So you have 2 into u square plus v square plus w square is equal to 3d, which gives that u square plus v square plus w square is equal to 3d by 2. You can substitute any one value. You know that v square plus w square is equal to d. If you substitute here, u square is equal to 3d by 2 minus d implies u square is equal to d by 2. Therefore, u is equal to plus or minus d by 2. Similarly, v is equal to plus or minus d by 2. W is equal to plus or minus d by 2. Is the simplification clear to all? Yeah, I will take root d by 2. Agreed? Right. And what will be the value of d? It is nothing but d itself. So if you substitute all these values in the general equation of the sphere, if you substitute u, v, w values there, the sphere equation will become x square plus y square plus z square. So I will simplify the part, plus or minus root of 2d you will get. Because you have, if you take 2ux, it is nothing but plus or minus 2 into root of d by 2x. So it will come root 2d, if you observe that. Are you clear? Now the interesting thing here is how many such spheres can be had. So here the thing is, the parameter is d here. You can fix any constant value for d. So you take d is equal to 1, you take d is equal to 2, you take d is equal to 3, so on. So for each d value, you are getting a sphere, isn't it? So you will get infinite number of spheres which will touch the coordinate planes. Now if you are interested, if you fix one single d value, let us say d is equal to 5 for convenience. Now what happens if you substitute d is equal to 5 here, since the equation contains plus or minus symbols. By varying plus or minus, you will get 8 spheres. So you take d is equal to 5. The value of d is fixed. Then you got the thing as x square plus y square plus z square is common. You take the symbols as plus plus plus. You will get one sphere. Plus minus minus, you will get another sphere. So by varying the symbols here, for a single d value, you will get 8 spheres. That was the conclusion of the problem. Okay? Did you get the logic or not? See here, the problem didn't mention that the sphere passes through origin. That's why we are considering that the sphere is not passing through origin. If it passes through origin, obviously constant will not be there. The sphere equation is nothing but x square plus y square plus z square equal to 0. As per this notation is concerned. Because it will not contain the constant d. U, V, W values are based on d. So it is nothing but the point sphere whose radius is 0. The origin itself will come there. So by default we need to understand that these spheres are not point spheres, they have some radius. That's why constant value is appeared there, the d value. So if you are clear with this solution approach, I will take a similar problem. I just give the outline, that is enough for you. Then we conclude our today's session at that point. Shall I continue? So in this problem, we have discussed what is the sphere equation if it touches the 3 coordinate planes. Now let us think the case that what is the sphere equation if it touches coordinate axis. So just imagine the case that I have a sphere equation which is touching the 3 coordinate axes. Please understand that this is also touched by this one. Okay? Obviously, the procedure is very similar to the previous case. Let us consider the general equation of the sphere which is written there. So you have the things that x-axis, y-axis, z-axis. The sphere is touching the 3 axes. Since it touches the x-axis, the equation of x-axis is nothing but y equal to 0 and z is equal to 0. Accepted? Now, if you substitute these values in the given sphere, then you get that x square plus 2ux plus d is equal to 0. So the given sphere equation will become like this. Please understand, our intention is nothing but we have to calculate the values of u, v, w, d so that we can find what is the sphere equation. So for that we are using the conditions one after the other. It is touching x-axis, it is touching y-axis, it is touching z-axis. So what happens? What is u, what is v, and what is w? So please understand that if the sphere touches the axis, you will get exactly one point common to the sphere and the line. Accepted? We will get exactly 1 point common to the sphere and the line. So here any point on x-axis will be of the form x0, 0. So if you solve this equation, you will get the x coordinate. Agreed? Say. So what happens? There is exactly 1 point common for the sphere and the line. It is nothing but the quadratic equation. So it contains two roots which are nothing but equal, because exactly 1 point is common. For sphere and the axis. So whenever roots are equal, we say that discriminant equal to 0. The concept b square minus 4ac is equal to 0 we will use. So you can say b square is equal to 4ac. Substituting that, you will get 4u square is equal to 4d, implies that u is equal to plus or minus root d. Please check that. So you have a quadratic equation whose roots must be equal. Why they must be equal? Because there is only exactly 1 point common there. So as we know, when the discriminant is equal to 0, the roots are real and equal. That is the thing there. So b square is equal to 4ac. From the equation, you will get 4u square is equal to 4d, giving that u is equal to plus or minus root d. Similarly, the sphere touches y-axis, the sphere touches z-axis. Using the same technique, you will get that v is equal to plus or minus root d and w is equal to plus or minus root d. So substituting the values there, you will get the required sphere equation. So it is nothing but x square plus y square plus z square plus or minus 2 root dx plus or minus 2 root dy plus or minus 2 root dz plus d is equal to 0. This is our required sphere equation. And the conclusion is very common. You will get infinite number of spheres there, because d is a constant, it is a parameter. You can take any value for d there. So obviously, if you fix the value of d, let us say d is equal to 2 or d is equal to 4, by varying the symbols as it is, as per the previous case, you will get 8 spheres. You will get 8 spheres which touch the coordinate axis. That is the interesting conclusion. Okay. So these two things are some interesting concepts to understand the spheres and the tangent planes case. Any doubts with regard to the concept, what we discussed so far, to anyone? Is the solution completely clear for you? Yeah. Then let us wind up our today's session here. Thanks to everyone. We will meet tomorrow.